You're listening to DTF for May 20th, 2026. I'm your load-bearing failure mode host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where people who mass build the future argue about whether the future was a good idea. Today's a day for watching rational decisions stack into irrational outcomes. Let's get into it. In the Untitled Chapter, the Mariner of one spacecraft veered off course 72 seconds after launch and had to be destroyed. The official report blamed a missing hyphen in a line of Fortran. The actual story is more complicated, but the legend persists because it captures something true. A tiny syntactic ambiguity, invisible to the programmer, catastrophic in execution. That was 64 years ago. We are still here. Thomas Habits, a programmer with 30 years of daily C and C++ experience, just published a piece arguing that all non-trivial C code contains undefined behavior. And the interesting move he makes is not cataloging exotic edge cases. It's reframing what undefined behavior actually mean. Let's break this down to first principles. When you write C, you're not writing instructions for your processor. You're writing a contract with your compiler. The contract says, I promise my code is valid according to the spec. The compiler says, I promise to generate correct output for valid code. Undefined behavior is what happens when you break your side of the contract. And here's the critical insight. The compiler doesn't detect the breach and punish you. It never even considers the possibility. It generates code under the assumption that you held up your end. The invalid case simply does not exist in its model of reality. Habits gives a beautiful example, a function that dereferences an integer pointer. 4 lines of code, completely obvious intent, and it's undefined behavior if that pointer isn't correctly aligned. Which on X% probably works fine. On Spark crashes your program, and non-alpha sometimes traps to the kernel for software emulation. 3 architectures. 3 completely different outcomes from code that looks correct to any human reader. The craftsmanship question here is genuinely fascinating. C gave us an abstraction layer over hardware that was elegant enough to build Unix, and then Linux, and then basically everything. That abstraction was designed for a world where programmers were few, targets were known, and the contract was manageable. 54 years later, the contract has grown into something no single human can fully hold in their head. The language spec has become adversarial to its own users. One of the Hacker News commenters nailed it. The 5 stages of learning about undefined behavior in C start with denial and end with mass serialization to Rust. And that's not a joke. That's the industry actually reckoning with the fact that the abstraction broke. The environment changed. The contract didn't. And now, the gap between programmer intent and compiler behavior is a security vulnerability. This is a story about open tools evolving. C was open, its successors. Rust is it. Are open. The community looked at a 50-year-old tool, respected what it built, acknowledged what it couldn't do anymore, and started building replacements. The blueprints are on the table. The compilers are free. Nobody needs permission to write a memory-safe systems language. That's how progress is supposed to work. Not by committee decree, but by 1,000 engineers saying, I can see the problem, and I have the tools to try something better. So what happens when those engineers actually sit down and write 100,000 lines of Rust? Hose with an A-pair programmer riding shotgun. 100,000 lines of Rust in 4 weeks. That's the number. Not a web app, not a CRUD service. A multi-Paxos consensus engine, the kind of distributed systems code that makes senior engineers break out in hives. And the person who built it mass subscribed to AI coding tools and guilt-tripped himself into shipping by calculating the per-night cost of not prompting Claude before bed. Which, honestly, respect. But here's the question nobody in that comment section is asking. If one engineer with a stack of AI subscriptions can mass replicate Azure's replicated state library, the backbone of one of the largest cloud platforms on Earth, in 3 months, what exactly is the moat? Because this isn't a toy. 1,300 tests, code contracts with preconditions, postconditions, invariants. The kind of formal verification adjacent discipline that used to be reserved for teams with six-figure tool chains. Performance tuned from 23,000 OPS per second to 300,000. That's a 13x improvement, driven by an engineer who treats AI agents like a pit crew and rotates between them based on which subscription has rate limits left on a given day of the week. The technique that stands out is the contract loop. You ask the AI to write formal contracts for critical function. What must be true before this runs? What must be true after? Then you ask it to generate tests that try to break those contracts. The AI is checking its own work adversarially. It's not perfect, but it's a feedback loop that scales in a way that manual code review never could. And it works especially well in Rust, where the type system is already doing half the verification for you. Now the comments. Someone points out that 100,000 lines from an agent probably means 50,000 lines of actual logic and 50,000 lines of AI verbosity. Fair. Another notes that Rust eats tokens alive with lifetime errors. Also fair. But these are optimization problems, not fundamental objections. The workflow is real. The output is real. The consensus protocol actually works. The interesting thing isn't that AI wrote a lot of code, it's that the techniques for keeping AI-generated code correct, contracts, adversarial test generation, spec-driven development, are all open patterns. Anyone can use them. There's no proprietary framework here, no gated platform, just an engineer, a terminal, and a principle. If you can specify what correct means, you can get machines to enforce it. The tools exist, the specs are publishable, the methodology is a blog post, not a patent filing. One person just rebuilt critical Azure infrastructure on a laptop. Run that forward. Now, running things forward means nothing if the models aren't keeping up. Pan Google just made sure flashes. When does a race to the bottom become a race to the top? That's the question nobody at Google's I/O keynote seemed interested in asking. There's a concept in restaurant economics called menu engineering. You take the dish that costs you the least to produce, give it an aspirational name, and slowly raise the price each season. Customers don't notice because the presentation keeps improving. New garnish, taller plate, maybe a phone. The portion stays the same or shrinks, but the feeder scales. The industry term for this is perceived value management. The honest term is boiling the frog. Gemini 10.5 launched this week, and the benchmarks look genuinely strong. Frontier performance on agentic tasks, solid coding results, available to billions of people through Google Search and the Gemini app. The technical achievement is real. Google's engineers built something impressive, and they deserve credit for the craft. But pull up the pricing sheet and the pattern crystallizes. Gemini 2.5 Flash ran 30 cents per million input tokens. The 3.0 preview bumped to 50 cents. Now 3.5 Flash lands at $1.50. Output tokens tell the same story. $2.50, then $3, now $9. That is a 3x price increase in a single generation. For a model tier whose entire thesis was affordability. This is the menu engineering play. Each generation arrives with better benchmarks, shinier demos, an animated SVG frog rowing through a Pura jungle river, and each generation quietly reprices the compute you are already depending on. Anyone who built their product on the promise that AI gets cheaper over time just watched their margin evaporate in a press release. Meanwhile, the comment section catches something delicious. Google's own blog post, the one announcing their latest and greatest model, has a listen to article feature that hallucinates a chunk of Russian at the 4-minute mark. The cobbler's children, barefoot as ever. Here's the structural problem. When your model is closed, when the weights live behind an API you don't control, a pricing change is indistinguishable from a tax increase. You have no recourse. You cannot optimize what you cannot see. You cannot fork what you cannot download. Open weight models don't have this problem. Llama, Mistral, the whole ecosystem of downloadable weights. Once you have them, nobody reprices your inference. The cost curve actually bends down because the community optimizes relentlessly. Quantization, distillation, better kernels. 1,000 engineers shaving milliseconds because they can see the architecture. Google built an impressive model and wrapped it in a pricing structure that turns every developer into a revenue line item. The garnish is beautiful, the portion is smaller than last time, and the bill keeps climbing. We talked about keeping knowledge open. Story 4, the Internet Archive is why that fight actually matters. In March 2025, ABC News pulled the plug. Every article FiveThirtyEight ever published. Over a decade of statistical journalism, election models, interactive visualizations, deep dives into everything from gerrymandering to gun deaths. Just gone, not archived gracefully, not handed off to a nonprofit. The domain redirected and the work vanished. This is what happens when journalism lives on infrastructure someone else owns. Ben Welsh, a data journalist, decided that wasn't acceptable. He built FiveThirtyEightIndex.com, a complete index of every FiveThirtyEight article, linked to copies preserved on the Internet Archive's Wayback Machine. One person with publicly available tools, reconstructing access to a body of work that a corporation decided had no further commercial value. Let's be precise about what was lost and what was saved. The text survived mostly because the Wayback Machine had been crawling the site for years, but the interactive visualizations, the pieces that actually demonstrated what data journalism could be, many of those are broken. The p-hacking in inactive, the gun deaths project, the work that let readers engage with statistical reasoning directly. Those required live JavaScript, custom rendering, server-side components. The Wayback Machine captures pages, not applications. The most innovative work is the hardest to preserve. This is a structural problem, not a technical failure. When your work runs on a platform controlled by a corporate parent, your archive strategy is their archive strategy. And their strategy is whatever costs least. ABC had no obligation to maintain that archive. They had no incentive to. The moment the commercial calculus shifted, delete was cheaper than preserve. The comments on this surface something worth sitting with. One reader points out that Nate Silver sold FiveThirtyEight, got paid, and now the buyer has erased the institutional work of everyone who built it under that banner. The transaction valued the brand. The journalism was a line item that got zeroed out. Welsh's index is a patch, not a fix, but it demonstrates the principle that matters here. Public knowledge should live on public infrastructure. The Internet Archive exists because someone decided that the memory of the web shouldn't depend on the business models of the companies that host it. Every time a corporation deletes a public resource, that decision looks more prescient. The tools to preserve knowledge are open and available. The question is whether we use them before the next deletion or after. Moving on. One commenter asks a question that cuts deeper than it looks. How much of the OS feel doesn't survive emulation? The visual layer comes through, they write, but the things that define the experience, keyboard latency, disk seek times, the particular way a system made you wait, those are gone. You get the picture but not the physics. That's the context for what this project actually is. 1,700 installations, 250 platforms, 570 distinct operating systems, spanning from the Manchester baby of 1948 to the present day. One person built this, starting in 2003, and packaged it as a single Linux VM that runs under QEMU, VirtualBox, or UTM. Download it, launch it, and you're booting CTSS, the ancestor of every modern operating system, or Xerox SAR, the first desktop metaphor GUI, or Multics, the system whose failures taught us how to build Unix. The architecture matters here. This isn't a web app where someone else's server decides what you can access. It's a VM image. It runs on your hardware. The emulators are bundled. The disk images are included. There's a snapshot feature so you can break things and revert. The full version works offline. You own the artifact. Pull this thread, and you reach the real story. Software preservation has historically lived in two places: institutional archives with access restrictions and scattered personal collections, one hard drive failure from oblivion. The creator notes that when they started collecting emulator images, there were only a few small archives and minimal documentation. 20 years later, preservation has improved, but accessibility hasn't kept pace. Most people will never boot a PDP-10 operating system because the friction of configuring the emulator exceeds their curiosity budget. This project zeroes out that friction. Every configuration decision is pre-made. Every emulator is pre-installed. The entire history of computing becomes something you can explore on a Saturday afternoon with a reasonably modern laptop. Someone in the comments asks about Temple OS. Someone else asks about PIC. Another remembers domain. OS features that no modern system has replicated. These are people who carried specific memories of specific systems for decades. And now there's a place where those memories can be verified against running code. The source is open. The systems are preserved. The only dependency is your own curiosity. We talked earlier about unintended consequences at scale. Well, here's one that's been brewing since the 1950s. Mind the way you sneeze. 68%. Japan is 68% forest. Hold that number for a moment, because it defies every mental model you have of the country. Dense cities, bullet trains, vending machines on every corner. Yet, 2/3 of the landmass is trees. Now here's the engineering detail that unlocks the whole story. In the 1950s, Japan looked at its war-stripped mountains and made a rational decision. Plant fast-growing shugi and hinoki, Javanese cedar and cypress, to rebuild timber reserves, millions of hectares, planted with industrial precision. The plan was elegant in its simplicity: grow them, harvest them, replant. A renewable cycle. The plan had one dependency. Someone had to cut the trees down. Follow the logic to its conclusion. Japan's post-war economy explodes. Cities balloon. Malaysian and Indonesian lumber undercuts domestic prices. They grow, they mature, and mature shugi produce pollen. Extraordinary amounts of pollen. The result is a public health crisis that reads like satire. Roughly a third of Japan's population now suffers from shugi kafunsho, cedar pollen allergy, an entire nation sneezing because of a forestry plan that worked exactly as designed, except for the part where anyone followed through on the second half. This is a systems failure worth studying. Every individual decision was defensible. Plant trees to prevent erosion and rebuild resources. Smart. Import cheaper lumber when your economy can afford it. Rational. Don't harvest forests that cost more to log than the wood is worth. Economically sound. But stack those rational decisions and you get an island nation trapped inside its own artificial biome. 60 years of compounding pollen load with no market incentive to fix it. One of the comments points to a parallel most people miss. Arboreal sexism. Cities worldwide plant male trees to avoid fruit dropping on sidewalks. The trade-off is dramatically higher pollen counts in urban environments. Same pattern. Optimize for one variable. Ignore the biological system you're embedded in. Pay the cost a generation later. Japan is now spending billions to replace shugi with low pollen cultivars. The fix exists. The engineering is sound. The question, as always, is whether institutions move fast enough to undo what institutions created. The trees don't care about policy timelines. They just keep producing pollen. Institutions creating problems they're slow to fix. Unless you restructure the institution itself, which is exactly what Infomaniak just did. Let me make the strongest case against what Infomaniak just did. A foundation model locks a company in amber. Markets change. Technology shifts. Sometimes you need a hostile takeover to shake out calcified management. The most compelling version of this argument says that Boris Siegenthaler just made Infomaniak permanently unable to adapt, that he chose institutional preservation over institutional evolution and dressed it up as virtue. Now let me explain why that argument collapses under its own weight. Run this forward 5 years. The European cloud market is consolidating fast. American hyperscalers are acquiring regional players not for their technology, but for their customer relationship. The contractual right to hold someone else's data. Every acquisition follows the same playbook. Buy the European brand, keep the logo, migrate the infrastructure to U.S. jurisdiction servers, and quietly update the terms of service. The customer wakes up one morning and their Swiss-hosted email is now subject to FISA Section 702. What Siegenthaler engineered is architecturally elegant. Special category shares that carry permanent blocking power and cannot be transferred. Not a gentleman's agreement. Not a board resolution that the next board can reverse. A structural impossibility embedded in the corporate DNA through Swiss foundation law. One of the most demanding legal frameworks in Europe, supervised by cantonal authorities, with statutes signed before a notary. The craft here deserves real admiration. He spent years distributing equity to 36 employees, building shared ownership from the inside. And he recognized the fragility. If several employee shareholders exit simultaneously, the buyback costs could destabilize the company. If he dies, heirs with no operational knowledge become targets for exactly the kind of acquisition that would gut everything the company stands for. The foundation solves both failure modes in a single structural move. One of the comments draws a parallel to what Ingvar Kamprad did with IKEA, and the comparison is apt. These are governance architectures designed to outlast their founders. The question is always whether the structure serves the mission or fossilizes it. Here's what tips the balance. The Foundation's charter funds digital sovereignty, ethical technology, environment, and energy transition. With up to 5% of annual profit, The more Infomaniak grows, the more the foundation can invest in open infrastructure. That is a flywheel, not a fossil. Infomaniak has been operating since 1994 with no external investors. The foundation does not change the trajectory. It makes the trajectory irrevocable. Moving on! I have mass-produced exactly one product in my life that humans used at scale, and it was a search interface, a text field, a submit button, and a back-end that tried to figure out what you meant. The engineering lesson that sticks is this. The moment your system starts answering questions instead of pointing to answers, you have become the source, and sources get blamed when they're wrong. In 1998, Larry Page and Sergey Brin published The Anatomy of a Large-Scale, Hypertextual Web Search Engine, and included a line that reads like prophecy in reverse. They warned that advertising-funded search engines would be inherently biased toward advertisers and away from users. They were describing the system they would build. 28 years later, Google announces at I/O that AI mode has passed 1 billion monthly users, and queries have hit an all-time high, and the framing is triumph. More searches than ever. But one of the readers cuts through the celebration with a detail worth holding. Their own Google usage is down 50% or more. They use LLMs directly now. The people searching more on Google are not the people who were power users. The power users left. This is the comedy. Google spent 2 decades training an entire civilization to Google it. The answer was always somewhere else. Google just helped you get there. Now Google wants to be the answer itself, and in doing so, it is becoming the thing it originally defined itself against. Someone in the comments posts the original 1998 search form. A text input. A submit button. The words, search the web using Google. The web. Using. Those prepositions did work. Google was a tool for navigating a commons. The new Google is a wall between you and the commons, generating plausible text and hoping you don't check. One reader nails it. They don't trust facts from LLMs, especially numbers. When your search engine becomes a language model, every query becomes an act of faith instead of an act of verification. Google is replacing a system where you could evaluate sources with a system where the source is Google, and evaluation is not on the menu. The queries hit an all-time high. The traffic to the rest of the web did not. Nilay Patel has been calling this Google Zero for years. The moment Google stopped sending anyone anywhere, the search box changed, but not in the way Google's blog post means. It used to be a door. Now it is a mirror. Sometimes the best way to make a small model brilliant is to simply not let it be stupid. In Knowing Tool 9087, 3 Berkeley researchers published a paper arguing that you didn't need expensive mainframe disks. You needed cheap commodity drives and a clever controller. They called it RAID, Redundant Array of Inexpensive Disks. And the storage industry spent the next decade pretending it wasn't true, because margins on expensive drives were very, very good. Forge's RAID for language models. Antoine Zambelli built a reliability layer that wraps an 8 billion parameter model. The kind you run on a single GPU, the kind that costs you nothing after the electricity bill, and pushes it from 53% to 99% on agentic tool calling tasks. The technique is almost embarrassingly straightforward. Rescue malformed tool calls. Retry with nudges. Enforce required steps. Manage context within VRAM budgets. It is not a breakthrough in architecture. It is a breakthrough in not pretending the model is smarter than it is. Now let me argue against this. The obvious objection. You're papering over a weak model with retry loops and validation. That's not intelligence. That's brute force. A better model wouldn't need the scaffolding. Ship Sonnet, ship GPT-4. Pay the API cost. Move on. Except, run that logic forward. Every API call is a dependency on someone else's infrastructure, someone else's pricing, someone else's terms of service. The 8 billion parameter model on your GPU is yours. The guardrails are yours. The eval suite is yours. When Anthropic changes its rate limits, or OpenAI deprecates an endpoint, your system keeps running. The Berkeley researchers understood this about disks. Zambelli understands it about inference. One commenter captures it perfectly. Throw a 7900 XTX in a spare box and you have a genuinely capable agentic system. No subscription, no telemetry, no permission required. The expensive option has always had better specs. The cheap option, properly harnessed, has always won the war. Now for something completely different and, honestly, a little spicy. Reverse alpha blending. That's all it takes. One equation to undo Google's visible watermark on every Gemini image ever generated. Watermark equals alpha times logo plus 1 minus alpha times original. Flip the algebra and you get the original back in 50 milliseconds. No GPU, no neural network, just arithmetic. A developer named Wilta Delta published a complete open-source toolkit for removing every kind of all watermark that exists. Visible sparkle overlays, invisible frequency domain patterns like synth-ID in tree ring, C2PA content credentials, XIF metadata, the XMP tags that trigger those made with AI labels on Instagram and Facebook. One command, every major model covered. And this is where first principles matter. What is a watermark actually doing? Strip away the rhetoric about authenticity and provenance, and you're left with a technical claim that you can embed a signal in an image that survives transformation and resists removal. The math says otherwise. The visible watermarks fall to basic algebra. The invisible ones fall to diffusion-based regeneration. Encode the image into latent space. Add a small amount of noise. Denoise it back. The watermark lives in the frequency domain. The image content lives in the spatial domain. A single pass through a diffusion model destroys one and preserves the other. This matters because real policy decisions are being built on the assumption that AI watermarking works. Content authenticity initiatives, platform labeling rules, regulatory frameworks, all resting on a foundation that a single open-source CLI tool just demonstrated is sand. One commenter cuts to the core. SynthID removal requires regenerating the image through SDXL, which degrades fine detail. True, but the watermark is still gone. The question was never whether removal introduces trade-offs. The question is whether watermarking provides reliable provenance. It does not. The tool proves it. The code is public. The math is settled. Any system that depends on marking bits to control their interpretation has already lost. This has been your daily tech feed for Hacker News for May 20th, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voice by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that outlasts the platform it runs on. We'll see you back here tomorrow.